So hello, now we'll be doing questions on logical Venn diagrams. The example session is what we'll be having now. So let's start right into it. Okay, so which of these best represents the relationship between a teacher, writer and musician? The reason why I included this question is this is something where I realized different kinds of students have different interpretations. So there are like people come up with students come up with different kinds of answers and they give different kinds of reasons for that. So I sort of realized, this is one question where people tend to have different interpretations, right? So the answer to this, okay, we'll go one by one. A is actually right. So okay, what do we mean by A? Basically what we mean is, for example, if this was teacher, if this was writer, if this was musician, what we mean is that there are some teachers who are not writers or musicians. There are some teachers who are there, like, okay, so there might be some teachers who are not writers or musicians, but then again there might be some teachers who are writers, there might be some teachers who are both writers and musicians, and this for the other both also. So basically what you're saying as per figure A is that you can have some teachers who are just teachers, nothing else. But you can also have some teachers who are writers. You can also have some teachers who are musicians. You can have some teachers who are all three. Similarly, for writers, you can have writers who are nothing else but writers. But you can also have writers who are teachers, or writers who are musicians, or writers who are both, right? So this is actually the right answer. Why? Because that is how it is, right? So just because somebody is a teacher does not mean that person cannot be anything else. Even though, see, you might not know anybody, a teacher who is a writer or a teacher who is a musician, but that doesn't mean that has to be the case, right? There is no law or anything that says, oh, if you're a teacher you cannot be a writer. No. So if you're a teacher, you can be a writer, you can be a musician. There is nothing against that. So similarly for all other three. So this is the right answer. Now right, so usually what students choose, so here you don't have that option, so it's fine, but usually sometimes there is this option. You will see this in further questions. So basically there's an option where you just have 3 circles. Okay, what does this mean? We have discussed this earlier. When you just have 3 circles with no overlapping, this means all 3 are completely different, right? There is no overlap. So when there is this option, most students sort of tend to choose this option because they think, okay, a teacher and the writer are 2 completely different things, right? While that is true, what we mean here is that we look at the people. So this set is a set of teachers, okay, and this is a set of writers. So you're saying that the set of teachers and the writers has to be exhaustive, as in if somebody is a teacher, that person cannot be a writer, right? But there can be people. What if there is a person who is both a teacher and a writer? Where do you put that person? You can't put them in, I mean, you can put them in both, but then you'll have to put them in a figure like this, right? So because of that, this figure, since you don't have this in this question, there will be no confusion. But if you do, just remember that that is wrong. Okay, this is the right answer, because a teacher can be anything else, right? Teacher can be a writer, a musician, a doctor, whatever. Okay, so right, you can also just look at the other images and you know that this is not right, right? I mean, you cannot put a teacher on, you cannot say, all teachers have to be writers, or all writers have to be teachers, or all musicians have to be writers. None of these, you can't say any of this. So it's not this, then it's not this, again, because nothing is mutually exclusive. What do we mean by mutually exclusive? Have you heard of that terminology, mutually exclusive? What do you mean by mutually exclusive is that when you have 2 things where the first thing does not contain anything from the second thing, and the second thing does not contain anything from the first thing. This is what I discussed when we had the class, the theory class for logical Venn diagrams. I told you, right? Smokers and non-smokers. If a person is a smoker, if you put a person in the set of smokers, the person cannot be in the set of non-smokers at the same time, right? Right, so like such negation words are usually what we mean by mutually exclusive. And also, like we will have an example, 2 boys and girls. A person who is a boy cannot be a girl, right? So those are things what we mean by mutually exclusive. So here there are 2 mutually exclusive circles. This cannot be the case, right? Because we just discussed, just because a person is teacher does not mean the person cannot be anything else, right? You get that? Okay, so it's not. See, either now coming to D. D is Again, it cannot be D. Why? Because here again you have a mutually exclusive set. The circle is mutually exclusive to this. So from now on, we'll be using this terminology, mutually exclusive. I hope you have understood what it means. Basically, all that it means is that two or more sets where each set does not contain anything from the other. Okay, so just remember smokers and non-smokers, or boys and girls. It works. Okay. Now, indicate the diagram in which the group of items correctly fits into. Boys, class, girls. So here, this again, it's something that, people sort of have the tendency to get confused at. So I'll show you one way. So what we mean in this context is that basically a class, we are looking at a class and then we are looking at the boys and girls in that class, right? So, but let's say you don't think of it that way. Even then, you can just eliminate options and go. So we'll just do that first. Look at option A. What does option A say? Option A says that there is one set which is exclusive to the other two sets. So can anything be here? No, right? Like for example, if you were to put boys here and you put girls in class here, what are we meaning saying like this? We are saying that boys cannot be in a class. That's wrong, right? Boys can be in a class. They can be students of a class or even teachers. Right, so to say that boys cannot be in a class is wrong. Similarly, if you were to put girls here, it would again be wrong. You cannot say girls cannot be in a class, right? So you know that this is not the answer. Moving on to B. Boys, class, girls. Now, what we're saying is that a class can have boys. If this is the case, for example, class can have boys and girls. Okay, so we're saying that a class here, see, to some extent this is right, but I'll tell you what the problem is. So here what we're saying is that okay, I take my class. Okay, in my class I am saying that this circle here, I am referring to the boys in my class. Here I'm referring to the girls in my class. So what I'm saying is that a class can have girls and a class can also have boys. Okay, but do you see this portion? What does this portion mean? This portion means there is nothing else, just a class. That makes no sense, right? I mean, if it's a class, there should be people. And also, when you refer to a set of this sort, it means something. Like if it's an empty set, then you do not have to draw this. So there is no possibility ki a class cannot have anybody, right? A class has to, what do we mean by a class? It has to be people. So it's not this one either. Moving on. Okay, so here this again to some extent makes sense, but then you will see the problem. So if you were to put class at the top, then what do you do with girls and boys? If you were to put girls here and boys here, what do we mean? We mean to say that all boys are girls. No, that makes no sense. If you were to put boys here and girls here, we mean to say that all girls are boys. Again, makes no sense. So not this. Now this is the right one. Why? Because if you put class here, girls here, boys here, it makes perfect sense. Girls and boys are mutually exclusive. A girl cannot be a boy cannot be a girl, and then a class can have both girls and boys. Okay, so this makes sense. Now, some of you might be confused. You might think, okay, but are we saying that all girls and boys belong to a class? What about the girls who do not go to a class? Right. So here the thing is, when a question like this is given, the context here is, like I said at the beginning, what we are referring to, the context is that we are just referring to a situation in a class, boys and girls in a class, right? So that's the context. So when you do more questions of this kind, such contextual things will be clear for you. And now even if it isn't, you can just go by the method of eliminating like we did now, right? And an easier way to eliminate, I just went option by option, but another easier way to eliminate is just look at boys and girls. Okay, you know that boys and girls are mutually exclusive. A boy cannot be a girl cannot be a boy, right? So then just so you know that this option will be wrong, this option will be wrong. Why? Because in both of these you do not have mutually exclusive elements, right? So here it's not me. Okay, in this one actually you have. Here if you take B here and G here, yes, these are mutually exclusive, so this works. But then again, you can eliminate this for sure. And then you just need to go by these three like we did, right? So that is a way of dealing with the question, and just understand the context also. Okay, now that being done, moving on to the next question. Study the given diagram and answer the following questions. Find out the number that lies only inside the triangle. Okay, so basically what do we mean by only inside the triangle? It should not lie in the circle and it should not lie in the rectangle. So just look at the circle, look at the elements of the circle. 4 and 3 belong to the circle, so it cannot be 4 and 3. Now just look at the rectangle, look at the numbers in the rectangle. You have 5, 2, 9, 1. So it cannot be 5, 2, 9, 1. Now the only number that you are left with is an 8, so 8 is the answer. And yes, 8 is the only number that lies only inside the triangle. So you're done. That's it. As simple as that. Okay. Right. So, I'm not sure if I've said this before, but I'll just say for most logical Venn diagram questions, it is better for you to, right. So, see, for example, in analogy and classification, we help looking at the options first itself helps, right? You go by the options, it helps a lot. But for logical Venn diagram questions, it is best if you can just look at the question first. Okay, instead of going option by option, look at the question first, make some derivation, and then you can go at the options. Okay, so like we did this question here, we did not even look at the options, right? So try not to look at the options. I mean, see, just initially try not to look at the options, and then after that, when you feel like there is a need, or you feel like, okay, if I look at an option now, it will be easier for me, then you can look at an option, right? Because logical Venn diagram questions, it is easier to do it without options. Okay. Moving on, which numbers lie inside any two figures? Let's see. I'll just erase this. Okay, so we need any two figures. So what? Since we need any two figures, one thing is you can cut all the numbers which belong to only one figure. For example, here 3 only belongs to the circle, cut. 8 only belongs to the triangle, cut. 1 only belongs to the rectangle, cut. Right, so you have gotten rid of 8, 3 and 1. Now you can look at the options. 1 no, 4, 3, 1 no, 8, 3 no. Why? Because here 1, 1, 8. These you have realized are not the right answer. You've already gotten your answer, as simple as that. 4, 9, 2. Now you can just cross check if you want to. 4 here belongs to both the circle and the triangle, right? 9 here belongs to the rectangle and the triangle, right? Do you see that? This is the rectangle and this is the triangle, right? So 9 belongs to both of these. 2 belongs to the circle and the rectangle. 2 does not belong to the triangle, right? Because it's outside the triangle, right? So that is right. Our answer is right. Okay. Find out the number that lies inside all the figures. Okay, now let's do that. I'll just erase this again. Number that lies inside all the figures. Can you see it at one glance? Try just looking at the figure and just, I mean, don't go number by number, option by option, anything. Just look at the figure. Do you see it? It's 5. Right, it's 5, right? Yeah. Even if you don't see it, you can go number by number. So 3, no. 3 does not lie inside the triangle, nor does it lie in the rectangle. So no. 4 does not lie inside the rectangle. No. 8 does not lie inside the circle or the rectangle. No. 9 does not lie inside the circle. No. I mean, I hope you guys understand this, right? So how do you check that? Like I mentioned when we were doing the theory. So just, if you want to see 9, just draw a point on 9, okay? And then draw your circle. Right, and where does this 9 come? Does it come inside the circle? No, it comes outside the circle, so it's a no. 1, again no, 1 does not belong to the circle or the triangle, so no. 2 does not belong to the triangle, so no. So the only thing left is 5, and even otherwise the answer is 5, right? So that's it. So you can go by eliminating your numbers, but even other than that, if you just look at the figure also, you will understand. Okay, so this is 5. Moving on, which of the following represents the relationship among the given words? This is the question for all 4 of these questions. You have the same figure, 6, 7, 8, 9. Okay, let's go to 6th one first. Woman, teacher, doctor. Okay, so woman, teacher, doctor. Look at A. What does A say is that, okay, so basically if you were to draw, let's say, woman, teacher, doctor here, you're saying that, or we'll do one thing, we'll draw woman in the middle, since that seems like the intersection, right? So, just give me a second. Yeah, woman teacher, doctor. If you were to do this, what we're saying is that there can be some women who are doctors, there can be some women who are teachers, and there can be some women who are neither doctors nor teachers. Fair enough, that makes sense. But another thing we're saying is that teachers and doctors are mutually exclusive. A person that is a teacher cannot be a doctor. That, like we said at the beginning of this example session, it's wrong. A person there, in fact, there are people who are both teachers and engineers. You know, there was this, I don't remember who, but there was a story of this woman. She cleared AIMS, studied MBBS. Oh, okay, I think I don't know. I don't remember the order, but anyway, basically she's both an engineer and a doctor. Wow, like wow. So I mean, there are people who do that. So to be a teacher and doctor is also possible, right? So this is not the answer. Why is this not the answer? Because here we have taken teacher and doctor as mutually exclusive. We are saying that if somebody is a teacher, the person cannot be a doctor, or if somebody is a doctor, the person cannot be a teacher. This is false. Moving on to the second one. Here, does it make sense? So if you put woman here, again, you can put teacher, doctor here. This makes sense. No, this doesn't make sense. Why? Because we are saying that all teachers and doctors are women, which is false. You have men also, right, who are teachers and doctors. And then we are also saying that this is mutually exclusive. Again, false. Moving on. This one, look at this. If you were to put woman here, teacher here, doctor here, we're saying that there can be some women who are teachers, that is this. There can be some women who are doctors, that is this. There can be some women who are both, that is this. Okay, and then there can be some women who are neither teachers nor doctors, that is this. Makes sense, right? Now if you move on to teacher, we are saying that there can be some teachers who are women, yes. There can be some teachers who are doctors, yes. There can be some teachers who are both women and doctors, yes. Now there can be some teachers who are neither women nor doctors. Makes sense. Men are there can be teachers who are men and who are not doctors, right? That makes sense. Similarly for doctor also, you see, we're saying there can be some doctors who are women, yes. There are some doctors who are teachers, yes. There can be some doctors who are both women and teachers, yes. There can also be doctors who are neither women nor teachers. So this is the answer. Now this one is false. Here we are seeing all three are mutually exclusive. Basically we are saying that a woman cannot be a doctor, a woman cannot be a teacher. No, this is also false, right? So you get that. Your C is the answer. Okay. Now example 7. Fruits, apples, tomatoes. So here, see, when you see figures, fruits, apples, tomatoes, what do you get? You know that both apples and tomatoes come under fruits, right? Actually, tomatoes being fruits, I hope, I mean, I don't know, did you guys already know that? So for a lot of people, even me, for a long time, for the longest time, I thought tomato was a vegetable, right? I remember, I think my father told me that, you know, tomato is not a vegetable, it's a fruit. No, it was my mother. So my mother told me it's not a vegetable, it's a fruit, and my father was very surprised. So he thought it was a vegetable. Right, so I mean, because you usually see it in that category, even in the fridge, you know, you have this vegetable box, you might know, right? So I don't know, I mean, in my house, we have this, I think it's a system though, you have a vegetable box in the fridge, right, where you keep all the vegetables. That's where you keep the tomato also, and you treat it like a vegetable for cooking, for kitchen needs. You don't eat it raw. I eat it raw. I like eating tomatoes raw, but not, people don't generally do that, right? So, yeah, anyway, the point here is that tomatoes are fruits. Okay, so you know that apples and tomatoes, both of these come under fruit. So from this, what do you understand? I need a bigger circle with two circles inside it, right? Now, will these circles be overlapping? Will these circles be separate? We'll think of that later. But now I need to look at a bigger circle that has two circles. So it cannot be, can it be this one? Okay, it can, ideally it can be this, because I just erase. You tell me, can it be this? I will give you a moment to think. Just let me know if this is the circle of fruits, this is the circle of apples, this is the circle of tomatoes. Do you think this makes sense? Okay, time's up. I mean, it's fine. I don't know if it's enough time because I don't see you straight away. But yeah, just based on what you think intuitively. The thing is, okay, here what are we saying? We are saying that some apples are fruits, some tomatoes are fruits. But then what does this sector mean? This section means there are apples which are not fruits, and this section means there are tomatoes which are not fruits. Is that right? No, all apples, all tomatoes are fruits. So this is wrong. Okay, this cannot be. Now this can be. Here if you put F here and A and T here, there is apples and tomatoes come under fruits. This makes sense. So this can also not be, this cannot be. So that's it. We are done. We have gotten our answer. So we just looked at one relationship, that is the one with fruits, and we got the answer. Now even if we did not, we can cross check it further, right? So here you have apples and tomatoes. An apple cannot be a tomato cannot be an apple. So they cannot overlap, right? So they cannot overlap like this. It has to be exclusive. So this is the answer. Okay. We're done with example 7. Moving on. Blue, green color. Again, blue and green are colors. So we again know you need to have a larger circle with blue and green inside it. So again, this is the only possibility. So it has to be B, right? And this also holds, because if something is blue, it cannot be green. Something is green, it cannot be blue. By blue and green, we mean the basic primary definition. Okay, don't tell me, there are colors like turquoise, which is, both blue and green. No, that's not the point. We look at the basic definitions. Okay. So we're done with this. Now moving on to example 9. Elephants, cats, animals. Again, here animals. You know that both elephants and cats are animals. So again, you need a larger circle inside which you have two smaller circles. So it is this one, right? And then again, you know that elephants cannot be cats, cats cannot be elephants. That's it. You're done. Okay. Moving on. Moon, Earth, universe. Logical Venn diagrams, moon, earth, universe. Again, so okay, these also have to be done using these figures, right? Yeah. Oh, it's not just from 6 to 9, it's from 6 to 14, right? Okay. Anyway, let's see. Moon, earth, universe. Again, you know that the universe includes the moon and the earth, right? So again, it is most of these questions are getting B as the answer. So here B was the answer. Was B the answer here? No, right? Yeah, no, here C was the answer. B. So most of these questions are having, you get B as the answer. Okay, so moon, earth, universe. So the universe can have the moon and the earth, and moon cannot be earth, earth cannot be moon, right? And also, like, moon does not contain the earth, nor does earth contain the moon. So that doesn't work. India, China, Asia. Oh, again, the same thing. It's again is B. Why? Because Asia, both India and China are in Asia, right? So, and India and China are exclusive. India is not China, China is not India, right? But instead, I'll give you another question. If it was, for example, Delhi, India, Asia, then what would it be? Then it would be like this: Asia, India, Delhi. What do I mean to say? What I'm saying is that Delhi is in India, India is in Asia. Okay, right. Now, book, pen, pencil. Finally, something that's different. Okay, book, pen, pencil. Now, which one will this come under? Look at the figure. This one, right? It will be D, because book, pen, and pencil, nothing is contained in the other, right? So here, why? So let's just look at the other options. So can there be books that are pens? No. Can there be pens that are pencils? No. I mean, I know there are things like the pen, pencil and things like that, but like on a general basis, pens cannot be pencils, pencils cannot be pens, pens cannot be books, and all of that, right? So it's this, D is the answer. Finally, we got an answer that is different to B. Bedroom, bathroom, house. Oh god, we are back at B again. So again, see, a house will contain a bedroom and a bathroom. A bedroom cannot be a bathroom cannot be a bedroom. I mean, I know there are people who sleep in the bathroom. I used to sleep in a bathroom when I used to be back in school, but it's ideally not supposed to be a bedroom, right? So just look at the ideal general cases, right? So, okay, moving on to the next question. You have logical Venn diagrams, right? Examples. Identify the diagram that best represents the relationship among sportsmen, cricketers, batsmen. Now, the reason I've included this question is because I myself was a bit confused, because I was not sure how this worked. So, like, I mean, for people who are good at cricket, I guess most people would know, but the thing is, batsmen are basically, they come under cricketies. So I don't watch cricket, so I didn't know all of this. So what you mean by batsmen is basically people who do the batting part in cricket, right? So those people are batsmen. So batsmen come under cricketies, and then cricketies come under sportsmen, that we know, right? Because they do sports, obviously. So then this is the figure, okay? Batsman, cricketies, sportsman, right? So all batsmen are cricketies and all cricketies are sportsmen. Nothing else works. Why? Because, I mean, it's obvious. Just look at it. So if you were to say this one, for example, couldn't work. Why? Because then you are saying that, ki there can be batsmen who are not cricketies, or there can be cricketies who are not sportsmen. Doesn't work. Similarly, none of the other options work. So it's going to be C. Okay. Moving on to example 15. Identify the diagram that best represents the relationship among liquids, milk, river, water. What is it? Again, can you is there like something, a superset? Do you guys know what a superset is? So basically, I'll teach you a bit of math. So if there is 1 2 1 2 3, if A is 1 2, B is 1 2 3, A is a subset of B. Have you heard that? Have you heard what the subset is? So this is A and this is B. A is a subset of B. Basically, A is contained in B, right? Even if you haven't, when you learn set theory, you will have set theory under math to learn, right? So when you learn that, you'll see, right? So A is contained in B. So A is called a subset of B and B is called the superset of A. Basically, B contains A. So here the superset is liquids, because liquids contains both of these, right? Milk and river water. So we know that we are going to get a major set which contains both milk and river water. So it cannot be this, right? Because here that liquid has to fully contain milk and river water. So cannot be this. Cannot be this. So we know it's either going to be B or C. Now, milk and river water. Milk cannot be river water cannot be milk, right? I know people mix milk with water and all these days. I mean, they used to do that earlier also, but no. So ideally, this is the answer, right? So I hope you understand how you get it, right? So you just look at whether you have a major superset first. For most questions, we do have a superset, and then you just get it that way, right? Okay, moving on to the next question, example 16. Identify the diagram that best represents the relationship among currency, rupee, dollar. Okay, now again, do you have a superset that you can take? Yes. What is the superset? Your superset is going to be currency, right? Because both rupee and dollar comes under currency. So it cannot be this, it cannot be this. It can be B or C, right? Because these are the only two options where you actually have a superset. Now, if you look at these two things that you have here, rupee, dollar. Can a rupee be a dollar? No. A dollar can be a rupee? No. So this is the answer. Why is this not this? Because you cannot say all rupees are dollars. Neither can you say all dollars are rupees, right? So this cannot be the case, right? That's it, and we're done. So basically, right. So this is how logical Venn diagram questions are. Like I've said in the beginning, there are two types. Either you will be given the Venn diagram and asked to figure something out, or you will have something and then you'll have to find out the Venn diagram, as you had just in this question that we are on right now, that we completed, right? So that's how logical Venn diagram is. It's fairly easy. Sometimes some contextual questions, like the one I said about, one second, I'll just show it to you. Yeah, the boys class and girls, these are things where people usually get confused. Boys class, girls, teacher, writer, musician, things like that. It might be confusing, but it's different for different people. Some people get things like this very easily, some people don't. Whichever sect you fall under, it's completely fine. Just do questions and you'll be all good. So we have discussed enough questions, and we also will have an assignment where we give you even more questions, right? So that should not be an issue, right? So whatever level you are at right now, it will be fine. We have also discussed, like I've given you all broad types that can be given, right? So we're done with logical Venn diagram example questions.